I have a video here about pH and pOH of substances, and we'll look at the acidity scale and briefly mention the basicity scale. First of all, let's take a look at three substances here: hydrochloric acid, water, and sodium hydroxide. So what makes an acid an acid? Well, there's lots of definitions for it. We're going to stick with simple Arrhenius definitions. An acid will have an H positive in its formula, like HCl. When you dissolve this in water, it produces an H positive aqueous ion and an aqueous chloride minus ion. It's the H positive ion that gives an acid its characteristic. So the more H positives you have in solution, the more acidic the solution is. Now what about a base, like sodium hydroxide? When you dissolve this in the water, you get an aqueous sodium positive ion and an aqueous hydroxide ion. It is the hydroxide ion that give bases their characteristics. So H positive is very reactive, and so is OH minus. So what are some general characteristics of acids? Well, they have a lower pH. They tend to be sour. Bases are higher in pH, and they're slippery to the touch, and they are bitter in taste. Now what about neutral? If you look at water normally written as H2O, I've written it as hydrogen hydroxide. This is called an amphoteric substance. It could be acidic or it could be basic. See, it's got an H positive in it, which could be like an acid, and an OH negative, which is like a base. Since it's got both, we're going to call it neutral. How do we measure pH? Well, pH is the minus logarithm of the H positive ion concentration. We do this because we kind of like regular numbers when we talk about concentrations of acids. Now let's take a look at pOH. pOH is the minus logarithm of the hydroxide ion concentration. And again, we want kind of numbers that are, relatively easy for us to deal with. These concentrations are going to be kind of small. And the concentrations are measured in molarity units. There is something to be aware of. pH plus pOH is 14. So when we add those two together, it equals 14. We're not going to discover that in this video why that's true, but it's related to the equilibrium constant for the dissociation of water. So now we got some ideas here for acids and bases. How do we handle some simple calculations in terms of pH and pOH? Now, first of all, there of course is a pOH scale and there is a pH scale. pH scale measures the acidity and pOH measures the basicity of a substance. By default, we have chosen to do the pH scale. But we don't want to forget about the pOH scale because there always is hydroxide in solution and there's always H positive in solution. Let's see how this works in simple calculations now. Here, of course, is our pH scale. 7 is neutral. As we go up in pH, 8, 9, those are weakly alkali. We can call it weakly basic. And then 11, 12, 13, 14, you're strongly alkali or strongly basic. You can actually go above 14, by the way. Now, what about going the other direction? 6, 5, and 4, those are weakly acidic. Notice how the pH gets lower as acid strength is getting bigger. And of course, strongly acidic in the 3, 2, 1. And you can go less than 1 also. So that's a basic idea of we're dealing with acids and bases here. Let's scroll down a little bit here. What I want to do is show you a couple of examples of how to calculate these things. It's not very hard at all. So let's say we have a hydrogen ion concentration of 10 to the minus 2. Now I want to take the minus logarithm of this to get my pH. Well, remember, a logarithm is what power is 10 raised to? Well, here 10 is raised to the minus 2. But we don't want negative answers. That's why we take the minus logarithm of it. So I'm going to record a 2 for the pH there. Now I know that pH plus pOH must come up to be 14. So I think to myself, what plus 2 gives me 14? That's 12. Now I want to get the hydroxide concentration. Okay, that's easy for us to do. We're going to go 10. Okay, and then I'm going to do a negative 12 for my answer. So notice how this 12 goes here, but you'll make it a negative, because remember the negative logarithm is what we take to get POH. So to get back to hydroxide ion concentration, you do 10 to the minus 12. Now what type of solution do we have? Well, pH 2, that's in our acidic range there. So I'm going to label this as an acid, or you can say acidic, either one. Let's try the next one here. A pH of 8. Well, that means my POH has to be 6. 8 plus 6 is 14. To get my hydrogen ion concentration now, I'm just going to go 10 to the minus 8. So you notice how that 8 goes there, but I got to make it negative. This one is going to be 10. And of course, I'm going to raise that to the minus 6. So 6 there, just make it 10 to the minus 6. Now what kind of solution is this? 8. I come over here. Okay, 8 is going to be my weakly alkali. So this is pH 7. This one is pH 8. So I'm going to label this one as a base. All right, let's just do one more. I'm going to skip down here. I see 10 to the minus 7 here. If I want the POH of that, I'm going to take the minus logarithm of that. So it's going to be 7. 10 is raised to the minus 7 power. So I'm going to record my 7, but I'm going to take that negative and make it positive. Well, I know pH plus POH must equal 14, so we have a 7 for my pH. This becomes 10 to the minus 7. And over here, well, I know 7 is this location right here, so I know that that is a neutral solution. So that's how we handle the pH scale and the calculation of pH, POH, and determining whether we have something acidic, basic, or neutral.